Welcome to this predicted paper from onmaths that is based on the advanced information given to us by the exam boards. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing. So we're going to start off by working out what 100% of 120 is. Well, that's obviously just going to be 120. And we're trying to get to 6%. So we always start off by working out 10%. It's always normally useful. And we just divide that 120 by 10, so we get 12. And we try to get 6%, so it'd be nice if I knew 5%. And 5% is nice and easy because we just halve that 10%. So that'd be 6. And if we got the 1% as well, we can get to the 6%. So to find out what 1% is, we just divide the 10% by 10 and get 1.2. So to get the 6%, we're going to add the 5% and the 1%. So we're going to add the 6 and the 1.2. And so we just do 6 plus 1.2, which is just going to be 7.2. And that's our answer. The first thing we need to work out is the fraction that Sarah will receive. Well, if Jane receives 9 over 10, then that just leaves how much of the numerator to match the denominator. So 9 plus 1 is 10, so it leaves 1/10 left for Sarah to have. And the reason that works is that the total amount needs to add up to 1, and 9 over 10 plus 1 over 10 is 10 over 10, which is just 1. So next we need to find out what 1/10 of 60 is. So we know that we divide by the bottom and times by the top. So 60 divided by 10 is 6, and then 6 times 1 is just still 6. So our answer will be £6. So to simplify 10 to 22 to 26, I'm going to have to find something that I can divide the 10, the 22 and the 26 by. The biggest number I can do that for is 2. So if you look, 10 can be divided by 5, but nothing else can. 22 can be divided by 11, but nothing else can. And 26 by 13, but nothing else can. The only thing we can divide all of them by is 2. So that will be 5 to 11 to 13. So the answer is 5 to 11 to 13. So football is represented as a quarter of this pie chart. And so if there are 60 students altogether, we just do 60 divided by 4 to find a quarter of it. And that's 15. So there are 15 people who picked football. The easiest way to compare fractions, decimals and percentages is to convert them all into decimals. So I'm just going to convert this percentage to a decimal, and to do that you just divide by 100. And I'm going to convert this fraction by timesing top and bottom by 10. And we know that 4/10 is 0.4. Then I'm just going to put all of these numbers in a place value grid, place value table. And we've got units, we've got tenths, we've got hundredths. Shouldn't need any more than that. So we've got 0.4, 0.43 and 0.27. Now what we do is we start on the left hand side and we find the smallest because we're looking for it in ascending order. And the smallest tenth is the 2 there, so it's 0.27. So this is our smallest number, 0.27. Now the next two are equal, so we look at the hundredths. And this technically has a 0 there, so 0 is the next smallest. Now 0.40 was 2/5, so make sure you have the original fraction in and not 0.4. And then the largest one is the 0.43, which was 43%. Just like when you're simplifying fractions, you can't have decimals at the top and bottom. You can't have decimals at the top, at the left and right of a ratio. So we're going to have to get rid of this decimal. And the way we're going to do that is just simply times each side by 10. And that will leave 4 and that'll be 60. Now we can simplify this further, because I can divide left and right by 2. So that'll be 2 to 30. And I can actually do the same again. I can divide them by 2 again. And that would be 1 to 15. Now you might have just divided by 4, and that would also give you the right answer. In fact, there's a couple of different methods that you can get the same answer with. Instead of doing 0.43 times 16, what I'm going to do is I'm going to do 43 times 16. So I'm just going to get rid of the decimal and just change it to 43. But I've got to remember what I've done. So how have I managed to do that? Well, I've times it by 100, and that'll be important at the end. And to do 43 times 16, there are loads and loads of different methods. Just pick whichever method you enjoy doing or that you find easiest. I'm going to do the grid method, but it by no means is the best method. It's just the one I'm choosing to do. So 43 is 40 and 3, and 16 is 10 and 6. So 40 times 10 is 400, 40 times 6 is 240, 10 times 3 is 30, and 3 times 6 is 18. Then I'm just going to add them all together. So 400 plus 240 plus 30 plus 18. And when you add those all together, you get 688. Okay. Now, the problem is that obviously this is not going to equal 688. What we've done though is we've timesed it by 100. So to find the answer, all we need to do is divide this, undo that times by 100, so divide it by 100. When we divide that by 100, we get 6.88. So when simplifying ratio, it's very similar to simplifying fractions, but instead of the same thing having to do the same thing to the top and bottom, you have to do the same thing to the left and right. So I'm going to start here by dividing both sides by 100, because I notice they both have 2 zeros at the end. So that'll give me 10 here and 34 here. Now these are both even numbers, so nice easy next one to do is dividing by 2. And we get, was it 17? And 5 and 17, well, they're both prime numbers, and so there's nothing we can cancel them by, so it's going to be our answer, 5 to 17. So we're asked to reflect this shape along the line y equals x, and y equals x is a diagonal line where all the x values are equal to the y values. So at the bottom here we've got x is 10 and y is 10, so that coordinate would be 10, 10. And then obviously this coordinate 4, 4, etc. So we need to reflect it across this line. And so if I pick a point, I'm going to pick the top one. We can see it goes 4 diagonals to hit that line. So 1, 2, 3, 4, so it will go another 4 diagonals. So that will be one of the coordinates there. And I'm going to do the same with the bottom one. So 1, 2, 3, 4, 5, 6 diagonals. 1, 2, 3, 4, 5, 6 diagonals. So it will be there. And then finally, I'm going to do this slightly harder one. So we've got 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Kind of goes over the other one, ends up here. So if we join these up, and we need to label it B. So the first thing we're going to do is write this as a ratio between the fractions. So we're going to have green to black. Now it says that a quarter of the counters are black, and therefore the remaining counters will be green. So if a quarter are black, that leaves 3/4 to be green. And what we can do here is on both sides of the ratio, what I'm going to do is just times it by 4. So I'm just going to times 4 both sides. So 3 divided by 4 times 4, because over 4 just means divided by 4. So 3 divided by 4 times by 4 just gets rid of the fraction. And 1 divided by 4 times 4 is just going to be 1. Now, this might surprise some people because they will probably think it's a ratio of 4 to 1, but we can show here that it's a ratio of 3 to 1. To answer this question, we need to know what an equation, expression, formula, and identity is. So the formula is basically an equation but for real world things. So area equals pi r squared. It's where the letters actually mean something. Expression is just algebra without the equal sign. So 5x plus 3 would be an expression. An equation has an equals and it can be solved. So you can find out what x is or find out what a is. And an identity is true for all values of that letter. So an example would be x times x equals x squared. That's an identity because that's true for all values of x. So looking here on the right hand side, we've got 3x plus 2x. But if we imagine x is 10, so 3x would be 30 plus 2x would be 20, 30 plus 20, well that will equal 5x, 5 times 10. And actually this is true for all values of x. And the reason it's true for all values of x is we know that 3x plus 2x, this right hand side here, equals 5x. They're the same thing. Now normally with an identity, it's shown with 3 lines. Now in the exam, this type of question, it won't be shown with 3 lines because that kind of gives it away that it's an identity. But this question is definitely an identity. And you can't solve it because it's true for all values of x. So yes, x could be 10, x could be a million, x could be a third, x could be anything. Whenever we solve, we've got to get rid of any fractions or brackets first. Now looking at this, there's no fractions, but there are 2 sets of brackets. We've got the set of brackets here, and we've got the set of brackets here. So we're going to expand them to get rid of them. And you can use any method you want. I'm just going to use this kind of grid method. So we're doing 4 times, and inside the brackets we've got 3x plus 5. So I'm going to times those out. 4 times 3 is 12, so that'll be 12x. 4 times 5 is 20, so that's going to be positive 20. And I'm going to do the same for the other set of brackets. Now on the outside of the brackets, we've got to be careful here. It's not a 5, it's a minus 5. And inside the brackets is an x and a 2. So minus 5 times x is minus 5x. Minus 5 times 2 is minus 10. So when we put it all together, we get 12x plus 20 minus 5x minus 10. And then the rest of it is just equals 52. So I'm going to start by putting my lines in because we're solving. And I'm actually just going to start by collecting the like terms on the left hand side. So 12x take away 5x is going to be 7x. And 20 take away 10 is going to be 10. Okay, now we need to get rid of the plus 10. So we'll take away 10 both sides. So we've got 7x equals 42. And then we need to get rid of the times 7. So we're going to divide 7 both sides. So x equals 6. I'm going to start just by writing out the equation, and I can put my lines in. Okay, we're asked to make x the subject, so we're going to first of all add 10 to both sides. In fact, I'm just going to move all this over a little bit so I've got a bit more space. Okay, so we're left with m plus 10 on the left hand side, and we've got 1/7 x on the right hand side. Now to get rid of the 1/7, what I can do is just times both sides by 7. So 7 brackets m plus 10 equals x. So x therefore would equal 7 brackets m plus 10, but it says expand your answer fully, so we're just going to expand the brackets. 7m plus 70. So here we're asked to find how many bread rolls we can make. We've got 89 kilograms and it takes 0.08 kilograms to make a bread roll. Something we can do is convert these into grams, or we can just keep it at kilograms, but I've got a neat little trick. And the trick is, if you've got a decimal when you're dividing, as long as you do the same thing left and right, you can multiply them by 10 or 100. In this case, we're going to multiply both by 100, because it will make the division a lot easier, because it will make this right hand side, instead of 0.08, it will just make it 8. The reason we can do that is 89 divided by is the same as 89 over 0.08, and as a fraction we can just times top and bottom by 100, so it would be this over 8. So now we can do the bus stop method. So 8 on the outside, and in fact I might use a straighter line here. There we are. And we've got 8,900 on the inside. So 8 into 8 go 1, 8 into 9 go 1, remainder 1, 8 into 10 go 2, remainder 2, and 8 into 20 go 2, remainder 4, and 8 into 40 go 5. Now it says how many bread rolls can we make. Now we can make 1,122 and a half. Well, half doesn't really count, so we're just going to say 1,122 whole bread rolls. Yes, we've got half a bread roll left over, but we are asked how many whole bread rolls can we make. To divide mixed numbers, we need to convert them to improper fractions first. And to do that, we just do the big number times by the bottom and add it to the top. So 2 times 5, which is 10, and add it to the top, which will be 13 over 5. And the bottom, the denominator stays the same. Divided by, and we're going to do 1 times 2, which is 2, add to the top, and we get 3. So it becomes 3 over 2. Then we're going to keep the first fraction, flip the second fraction, and change the sign. So it becomes 13 over 5 times, and then we're going to flip that, so it's going to be 2 over 3, times the tops would be 26, times the bottom, which would be 15. Now 26 over 15, there are 1/15s that go into 26, so that would be a big 1, and that leaves a remainder of 11, so it would be 11 over 15. So our answer would be 1 and 11 over 15. The most important first thing that we do is whenever you square something, you times it by itself. So we're going to rewrite this as x minus 15 times x minus 15. And then the way we approach this is exactly the same as we've done with the other ones. We're going to do a multiplication grid, and we're going to do x minus 15 at the top, x minus 15 at the bottom, then we're going to do x times x, which is x squared, x times minus 15, which is minus 15x, same again here, and then we've got a minus times a minus, which is a positive 225. Put all the terms together, now you can see here that we've got the x terms here that will add together. So that would become minus 30x plus 225, and that's actually our answer. So it's x squared minus 30x plus 225. There's a very specific way to draw a perpendicular from a line. What you do is you get a pair of compasses and measure roughly 3/4 of the way between A and B, and draw an arc from point A, and we're going to draw an arc from point B, and you can see that the two arcs intersect here and here. So what we're going to do is just draw a straight line that join up where they intersect. Leave your workings out, your arcs, on the page when you do this to make sure you get full marks. I'm just going to write the question out so we've got a little bit bigger writing to play with here. And it doesn't actually matter which method you expand these brackets with. I'm going to use Smiles and Rainbows. So we multiply the 8 by the 10x, which will make 80x, and multiply the 8 by the 4, which will make 32. Now here we've got a minus 5 on the outside, so we do minus 5 times 8x, which is minus 40x, and minus 5 times minus 4, which is actually plus 20. And a lot of students will write take away 20 there, but that is a minus 5 on the outside of the brackets there. So it's minus 5 times the minus 4 there will give you a plus 20. Then 80x take away 40x, which will give us 40x. And 32 plus 20, which would be 52. So our answer would be 40x plus 52. So we're looking to write a formula for the cost in pounds of hiring a microwave for X amount of days. So the cost is C, so it's going to be C equals, and it says it's going to be 55 pence a day. Now it wants the answer in pounds, so we need to convert this 55 pence into pounds. So that's going to be 0.55, and it's going to be 0.55 times the amount of days. Well, it says the amount of days is X, so it's going to be 0.55x. Then it says that there's just a one-off cost of £15, so you're going to have to pay £15 regardless. So we're just going to add 15 onto that. So the answer would be C equals 0.55x plus 15. So we need to first of all work out the amount of machine minutes it takes to make a toy. And what we do is we multiply the amount of machines by the amount of minutes. So 5 times 40, which would be 200. So if we had one machine, it would take 200 minutes to create one toy. Here we're asked, well, okay, what if we wanted a toy every 8 minutes? So we get the 200 and we divide it by 8. And when we do that, we get 25. So if we had 25 machines, we would be able to make it every 8 minutes. And the logic here is 5 machines. So this is machines, and this is minutes, is 40. Then 8 minutes, if you think about it, we divide that by 5 to get to 8. And so if we divide the amount of minutes by 5, we actually times the amount of machines required by 5. So this is called an inverse relationship. So if one doubles, the other halves. If one divided by 5, the other will times by 5. So our answer here is 25 machines. When we multiply numbers, it doesn't actually matter which order we multiply them. So we can do 2 times 4 times 10 to the power of 8 times 10 to the power of 9. 2 times 4 is 8, and when we multiply two powers with the same base, we add the powers. That's going to be 10 to the power of 17. So our answer is 8 times 10 to the power of 17. When it's said that y is inversely proportional to x, it means that y changes as 1 over x changes. And to write this in an equation, all we do is we just write y equals k over x. Now k is something we need to find. So what we need to do is find out what a value of y and a value of x are somewhere on the graph that would be formed from this, and we've got that in this question. So we know that when y is 7, then x is going to be 7.9. And what I need to do now is just draw my lines down. And what I'm going to do is I'm going to just times both sides by 7.9. And so we have k equals, and it'd be 7 times 7.9, which is 55.3. So we know that k is 55.3. So I'm just going to rewrite this equation here, or this formula here. But instead of k, I know that it's going to be 55.3. So our answer is y equals 55.3 over x. When we multiply numbers, it doesn't actually matter which order we multiply them. So I can actually rewrite this as 7 times 9 times 10 to the power of 2 times 10 to the power of 9. 7 times 9 is 63. And 10 to the power of 2 times 10 to the power of 9, we add the powers, so it'd be 10 to the power of 11. Now here we've got a problem. It looks like standard form, but it is not standard form. Because standard form has to be a number between 1 and 10, but not including 10. And here we've got 63. So what I'm going to do is just quickly write out what number this is. So we've got the decimal point here. And you don't need to do this, but I find it a bit easier to show what we're doing. So here we've got 10 to the power of 11. So it'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We fill these all out with zeros. And that's the number we've created here. A lot of zeros. Now, to make it a number between 1 and 10, not including 10, the decimal point, it needs to be here. So we want that to end up with 6.3 times 10 to the power of, well, let's work that out now. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's going to be 10 to the power of 12. Now you don't need to do all the working out I've just shown there. You just need to know when you convert that 63 into a 6.3, you need to add 1 to the power. So to answer this question, you need to just know the answer off by heart. There is a diagram that can help us actually get there. And if we just draw a right angle triangle and put the lengths as 1, not right angle here, we can use Pythagoras, a squared plus b squared equals c squared, to work out the fact that this is going to be root 2. Because it's an isosceles triangle, this angle here is going to be 45 degrees, and same with the bottom right one, but we're not interested in that. When we label it with our marked angle here, we've got the adjacent is here, and the hypotenuse is here. Now we know from trigonometry that cos x equals a over h. The angle is going to be cos 45, and a is going to be 1, and h is going to be root 2. Now, this is a bit of a strange one with 1 over root 2, because we need to actually be able to rationalise the denominator. And basically what that means, if you haven't done surds yet, or you aren't doing surds, is you times Tom 1 by root 2. And so we end up with root 2 over 2. So if you ever see 1 over root 2 is absolutely fine as an answer, but if you ever see the answer as root 2 over 2, the two are actually exactly the same. So writing 1 over root 2 is fine, or writing root 2 over 2 is also correct. So we're going to first of all realise that this is a right angle triangle and we've got two lengths and an angle involved, therefore it's going to be trigonometry. So we're going to just label the sides first. The one opposite right angle is the hypotenuse, opposite the marked angle is the opposite, and the one between the right angle and the marked angle is the adjacent. Now the adjacent doesn't have a number or a letter next to it, so it's not interesting, so get rid of that. Next we're going to do our trigonometry triangles. And so we've got SO, Ka, Toa. And we are just crossed out the adjacent, so we don't need this one and we don't need this one. And we're going to end up with SO, which is short for sine the angle equals opposite over hypotenuse. The angle is marked as x, so sine x equals root 3 over 2. You need to know from memory that sine 60 is root 3 over 2. And notice here that the x therefore is going to equal 60. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing.